Hello, everyone. How's it going? Can you guys hear me? Okay, cool. Thank you. Well, welcome to statistical theory. Nice to see you all. So the plan today is just to kind of introduce ourselves and then just go over the format of the course, how you guys are going to be assessed, and make sure that's clear if you have any questions. And then we can get started with some material towards the end of class. So let me just first kind of apologize. I've got a couple of dogs here. One of them we're fostering, the one that's in the crate. She barks. We went for a jog. I'm hoping she's tired and she doesn't make any noise, but I apologize in advance. She made it through the first class mostly. That was good. Okay, so all of our information. So let me just introduce myself. So welcome, Adam Spiegler. I prefer that you guys call me Adam. It's nice to see a lot of familiar faces, and it's nice to see some new faces. So welcome to the class. If my name sounds familiar, I'm also the undergrad advisor and the co-director of the undergrad program. So if you do have any questions about your degree progress or what programs we have in the math department, I can certainly help with that as well. And so the best way to reach me is by email. Obviously, I haven't been on campus since the last time I saw David and Yua last spring. So yeah, this is the best way to catch me. I've got office hours on Zoom. I might have to tweak these times a little bit, but they will be on Tuesday and Thursday. So I'll have office hours on the days that we don't have class. And if those, whatever times I set don't work, we can always arrange some time to meet. And in addition, we have a learning assistant in the class. So if you haven't taken a class with a learning assistant before, it's a fellow undergrad who has done well in the class and is here to help support us. So as class goes on, we'll do a lot of work in groups, and our LA, Yua, is going to be a big help with that. And Yua is also holding office hours as well. So I just want to give Yua a chance to introduce herself and say hello.
Hi, everyone. My name is Yue, and I double major in math and economics, also minor in data science. I'm your learning assistant this semester, and I'm excited about this semester. If you have any questions, feel free to email me or just drop into my office hour. Welcome. Thanks.
Yep, thank you, Yu. So yes, Yua was a student in last year, spring of 2020, where we had like a month of getting to know each other, and then it was remote after that. Okay, so welcome everyone. We have a fairly small class, which is good. So we've got altogether 17 students. So I just want to give you guys a excuse me, a chance to just introduce yourselves. Just say hi. This is my major. You might want to share what major you're in or where in the progress of the degree you're at. And so, yeah, it's great. Some of you have your cameras on, and that's awesome. Some of you do not. That's okay. I'll just request that if you are someplace where you're comfortable turning your camera on, it's really nice to see the face of students. And so please do. If you're someplace where that's not possible, there's no pressure on that. So I'm just gonna take some attendance, and when I call your name, if I mispronounce your name or you have another nickname, please let me know. And yeah, so let's see, Hafsa. Not here. Hey, Justin.
Yeah, here.
So, wait, are you majoring in math or?
Yeah, I am a math major.
Okay, cool. Welcome. And hello again, Max.
Hi, again. Again,
yeah.
you know.
So, sorry, Max, you mind just saying like what your major is?
Right, I am a math major. I'm not really sure what my focus is yet, but I'm ready to explore some stuff and figure it out.
Thank you, Max. Julie?
That's me.
Hey, Julie. Do you go by Julie or Juliana?
Both is fine.
Okay. And so do you mind just what's your, what are you studying here at CU Denver?
Math with a focus in statistics.
Okay. Well, good. This is a good class to take if you're focusing in statistics. You've come to the right class. Good. Welcome. Derek?
Yeah, I'm here. I have I'm going for applied mathematics.
Okay, cool. Nice to see you. Welcome. Karina?
Hi, I'm an applied math major as well.
Okay, cool. Nice to meet you. Shu Sen? Oh,
Yes,
this is-
here. I
did-
major in economics and minor in vice.
Okay. Did I pronounce your name correctly? Is it Shu Sen?
Yeah, correct.
Okay, great. Well, welcome. Are you, Shu Sen, are you here in Denver or are you back in China?
In Denver.
Okay, that's good. So you're awake. Okay, very good. Okay, well, nice to see you. Hoa, am I pronouncing that correctly as well? Hoa Jing?
Oh, here, it's Hua, but you can call me Hannah or Hannah, whatever.
Okay, thank you. Well, welcome. How about yourself? Are you here in Denver?
No, I'm in Beijing, China.
What time is it? Late.
Right. I'm
early.
in China.
Yeah. Okay. Yeah. Well, welcome. Thanks for coming. Yining.
Oh, thank you.
Yining, I don't think is here. Don't see you. Okay. So for anyone who is not here, maybe you're listening. I do record these just for everybody, and I post these on YouTube. So for anyone out there that is unable to come to class either today or in the future, I do record these. I understand life is kind of complicated these days. So if you have to miss a class, they are recorded. If you were unable to come today, this one will be posted. Usually it takes about a day for the video to process and get uploaded into YouTube. So all of the videos, all the recordings I'll put up in YouTube. Dan?
Yep.
Yeah, how's it
Yeah,
going?
so I was a mechanical engineering major just last semester, but I switched over to the dark side, applied mathematics.
The light.
Yeah.
Well, cool. That's a good choice. Welcome. Yukio?
Oh, hi, Adam.
Oh, hey. Oh, sorry. Yes. Yukian. Yes. How's it going?
Yeah, I'm fine. I'm still in China.
Yeah. And so you mind just telling everybody what you're studying?
Yeah, now I'm double majoring in economics and math. Yeah.
Yeah. Great. Had Yukian in several classes. I feel like we know each other well, although we've sadly never been able to see each other. Well, welcome.
Okay, thanks.
Is it Mei Ling? I don't think here. Okay. Hey, David. How's it going?
Hey, my name's David. I was a chemistry major, changing it to math. So.
Well, cool. It's nice to see you again, David. Yeah. Also, and I had a class in the middle of spring last year, so it was cool. We got to meet each other, and then it was remote after that. Okay, welcome, David. Jonathan, how's it going again?
Hello. I'm a fifth-year senior entering my final semester, majoring in mechanical engineering with a mathematics minor.
Whoop. Welcome. And Stephanie.
Hello, yes.
How's it going? What are you studying?
I'm majoring in math, focus in probability and statistics, as well as econ.
Okay, thanks. Well, welcome. Nice to see you again. Okay, well, thanks. So I want to just quickly go over the structure of the course, just so it's clear what the expectations are. So we are going to have, you know, I'm going to try and make this as seamless as possible, moving from what we would be in person to online. So we're going to have synchronous classes on Zoom, where ideally we can generate some good discussion with your classmates. We have a pretty small class, which is great for that. And so I think it's nice while we're all separated to have some time to actually see other people and connect with each other. But yes, these will be recorded as well. So if you can't make it to class, you know, there's no participation points part of the grade. I understand that that might happen from time to time. So the structure is going to be, we've got 2 exams during the semester, 1 exam during finals week, and that exam is not a final. It won't be comprehensive. So they're going to be like 3 equally weighted exams. Each of them is 20% of your grade, and the dates of these are tentatively scheduled on the syllabus. I can show you that in a second. And then, so you've got exams, homework, and reading quizzes. So the homework is 27% of the grade, and the reading quizzes are 13% of the grade. So how it works is these homeworks, these are typically due Monday at 11:59 p.m. Okay, so just before midnight on Mondays. This week is just going to be, or next week's homework is going to be a little bit different because, yeah, I'm not going to give you a homework assignment on Monday. We just had 1 class today. So next week, the homework will be due on Thursday. And then then after that, we'll kind of move towards Mondays. So just so you know, homework 1 is due next Thursday. And that is posted, so you're welcome to get started on it. We'll get through some material today so you can start working on it, and we'll get through the rest of it on Monday. These pre-class reading quizzes, they're gonna be before every class, or just about every class. So these are due, therefore, at 1:45 p.m. The class starts at 2. So the reading quizzes, they're going to be in Canvas. They're intended to be, you know, not that challenging. The idea is to just make sure that, you know, we've reviewed some of the basic terminology that we're going to need during the class, so that during class we can spend some time doing some of the more challenging ones. So it's kind of a way of saying these are some things that I think you guys can figure out on your own, and therefore we can come to class and work on some more challenging ones. The intention is not that they're very long. They'll be like 3 or 4 questions, mostly multiple choice. So, you know, I would say that students tend to do really well on them, and it doesn't take up too much time. It's just really just to check that you are thinking about some math in between classes. And so along with those quizzes, I'll put up videos. They'll be short, maybe like 5–10 minute videos that kind of discuss the topic, and then you'll have a quiz on very similar stuff. Any questions? So I'll just say.
Oh, actually.
Yeah.
What's your policy? Are these all closed note, or do you have open note? Open book?
Yeah, so
what's your policy on that?
Yeah, so for the exams, that's a good question. They're going to be during class. They'll be on Zoom. So everyone is going to be on, and on the days that we have exams, I will ask that people turn their cameras on, but you will be able to use study guide. Yes. So I'll leave it for you to create that. I'm not going to create it for you, but you're allowed to bring in like a study guide. Yes.
Cool.
Yeah. Well, but yeah, certainly we can get more into what you are and are not allowed to do on the exams as it gets closer. But yeah. Anything else? So I don't know if I said it, but you guys please just call me Adam, and I'm happy to keep this informal. If you prefer to like raise your hand, like the electronic hand that they have in Zoom, if you have a question, feel free. If nobody else is talking, then feel free to just unmute yourself and ask away. And there's also the chat that you can use as well. Okay. Yeah, so here's kind of the tentative plan for the excuse me, for the semester. So this is the course in statistics. We have a separate course in probability, Math 4810, but you need to know some probability in order to do statistics. So we're going to spend, the first couple weeks of the semester using reviewing some of the probability, not reviewing, just kind of going over some of the probability concepts that we're going to need. And so that first exam is going to be on probability and kind of the beginning of the statistics part. And then exam 2 is going to be dealing with some simulation ways of doing inference, hypothesis testing, and setting up bootstrapping. And then after exam 2, we'll talk about some of the more classical methods of doing inference. So really the main tools of inference are confidence intervals and hypothesis tests. So as far as the textbook goes, for the first month, the book that we're using is at Auraria Library digitally. You don't have to go onto campus. And you can just download a PDF straight from their website. So you actually can just read that textbook offline whenever you want. So that's super nice. So you don't need to buy anything for the start of the semester. For the rest of the semester, we're going to be using a book called Mathematical Statistics with Resampling and R. And the thing you want to be careful about is we are using the second edition of the text, which is a bit different than the first edition. And this too was available at the library. I checked a couple days ago, and all they had was the first edition. Last time I taught this class last year, they did have the second edition. So I am asking the library about what happened to the second edition. It's not something that you're going to need for another couple weeks. So hopefully we'll see what's going on with that. If you want to purchase it, I did put some links online to like Amazon to get it or wherever. The bookstore has some copies as well. So any questions about what materials you would need to get for this semester? Okay, and in addition to the text, we're also going to use do some computations, and we're going to use R. And this is free. So if anyone has heard of this before, it's like a programming language that's pretty common in data analysis. We'll get to that probably in about 3 weeks or so, but I'll put some instructions up how to install R, how to install R Studio. All of it is free, so that is not something you would need to purchase. And it's not optional. We're going to be using that quite a bit. And for anybody that's taking, I guess this might be a prereq for that class, but Math 3376, which is data wrangling and visualization, is a more comprehensive course in R. So we'll use R a little bit here, mostly taking a look at here's code. How can we tweak this code to suit our purposes as opposed to like writing everything out from scratch? Okay, any questions? Okay, so I think we more or less have talked about this. Yeah, so just make sure that your screen name has whatever name you would like to be called by. So if you have a nickname, feel free to change that. We talked about the cameras, yeah, and otherwise, yeah, be prepared to talk during class. So in class, we'll be working with breakout rooms, maybe for like a quarter, a third of the class will be talking with classmates, and then the rest of the class will be talking about stuff together. Excuse me. It has not been an issue, but I probably jinxed myself about Zoom crashing. Last semester, Zoom was really good. It's bound to happen one of these days. Might happen to me. If it happens to me, you all will stay in the Zoom room, so just don't go anywhere. It's probably my internet might have dropped for a second, and I'll log back in. If the problem is more severe, then I'll get on my phone and post an announcement in Canvas using data plan if I don't have internet. So if the problem is more severe, then I don't want you sitting in an empty Zoom room for 10 minutes, I'll let you know. But hopefully that's not an issue. And if you happen to have a problem, then I think the things that generally work are just log out of Zoom and then log back into Zoom or restart your computer. But don't freak out. Again, things are being recorded. So if you miss 10 minutes, you can catch it on the recording. Okay. Yeah, so last thing I want to do is just take us to the Canvas site. If you haven't seen that, just so you know where to find things on our site. So probably starting next week, the home page, the opening page is going to be with the modules instead of the welcome. And this is how I organize the material. So here's kind of the general information. Here's stuff about the textbooks. So if you click over here, this, I believe, should take you right to the link on Auraria's library to download a PDF. And here's here's a link to purchase the second edition on Amazon. And I'm gonna, again, follow up with the library about whether they'll have the second edition. They do have the first edition, so you could use that, but it has changed a little bit. And so I would say week 2, this is what a typical week might look like. So this is for next week. So these aren't links, it's just indicating what sections of the textbook you should read. I can't post those sections because this is published in copyright, but you all have access to that for free again. So this is just saying, okay, on Monday's class, we're gonna focus on sections 1.4 and 1.5 in the probability text by Carlton and DeVore. So it might help to kind of just look over that material beforehand. I haven't posted any videos yet because I'm not quite sure how far we're gonna get today. So depending on how far we get today, down below this section, you'll see some links to videos. And the idea is to watch like Monday's video and then come over and try the quiz. So when you click on this, it's locked right now. It's going to be available tomorrow. So just keep an eye out for that. And the quiz, again, is going to be, usually just a couple multiple choice questions. So nothing to stress too hard about that, I don't think. Students tend to do pretty well on these in last semester. And yeah, so, and then the last part is everyone's favorite part, and this is like the work that you need to do that week. So next week, 2 reading quizzes, and then the homework is due on Thursday. And that homework is up. I don't know if this is, the homework assignment is up, and when you submit it, obviously it's going to be electronically. I just ask that you submit it either in Word or as a PDF. So if you want to type it up, feel free in Word. If you just want to write it out on paper, then Canvas is not really good about uploading images. So I just ask that if you write it out on paper, use an app to convert those photos into a PDF and just upload one single PDF. And it'll be a lot easier for me to read it and for you to read my comments on that as well. Yeah, and so if you haven't seen how to update these things, if you haven't taken a Zoom class, you just hit submit assignment, come down here, choose the file, and submit. That's it. Any questions about that? So you guys are certainly welcome to, work with each other. I just ask that it is collaborative, everybody's contributing, and that if you do work with somebody else, you hand in your own work and you kind of summarize things in your own way, but it's totally fine to get some help with others. And are there any other questions, anything that I'm missing? Okay. Great. Okay, so I want to start with a very classic problem in probability. Helps if you can see what I'm doing. So it's called birthday problem. I don't know if anyone's familiar with this. The idea is a bunch of people are in a room. Works better when we're actually in a physical room. A bunch of people are on Zoom together. We can apply it in this way as well. And the question is, what are the odds of having a match? So let's say, for example, here, we've got 15 people on Zoom. And so for this to work out, pick one friend, family member that you're going to bring to the party. So there's going to be you and your guest. So altogether, since there's 15 of us, I think that's right, then we'll have 30 people in the room. So if we've got 30 people at the party, what are the odds that somebody has the same birthday? So think of your friend. It helps if you know what their birth date is. That's important here. And let's see if we have a match between the 15 of us and our guest. How likely do you think this is? Would you be surprised or not surprised if we have a match?
Surprised.
Okay,
we only
well,
have 14 people or whatever.
Yeah, so we got 15. I'm going to include myself, and again, we're allowed to bring someone, so we're going to have 30. So I know the odds here, and I'm going to bet you guys. I don't know. It's kind of hard to bet you something when we're on Zoom. I'm pretty confident we're going to have a match. I don't know any of your birthdays, so let's see. So I'm going to open up the chat, and we can chat this way. I'm just going to say we'll start with January, and so who has a birthday in January?
You want us to chat and type our
Yeah.
birthday?
Does this also include our guest?
Include your guest, yeah. And if you do have a birthday in January, tell me what it is. Like January, whatever. January 14th, you have a January 3rd, 27th. Whose birthday is January 27th? Happy birthday.
That was mine. It did a direct message. I don't know if you wanted us to do a.
Okay.
We can only do a direct message right now.
Okay, I just changed that. So I'll just summarize. So David had a January 3rd. Derek had a January 14th. Dan had a January 27th. Karina had a January 19th. And Christina had a January 15th. So that was not a match. Yes, I'm worried. That was not a match. We were really close. We had a 14th and a 15th, but that doesn't count. Okay, how about February?
Are we still putting up?
Bam, we're done. Usually this goes like until like, that ruined it. Usually we go into like August and then like we're in November and everyone's getting all stressed out. Okay, cool. So are you the 27th, David, or is that somebody else?
That's me.
And Stephanie?
That's my brother.
Okay.
I'm not your brother either.
Fair enough. Okay, well, let's see how many other matches we can have. So we have one match so far. Let's try, we're on March.
I don't know if this counts, but my sister-in-law has the same birthday as me.
Oh, that's cool.
So I was going, yeah, I don't know.
Well, yes, you're not allowed to
That
bring
was my
someone that
family.
has the same birthday as you. That ruins it.
Yeah.
Let's see. So we have that's it for March. April. Yeah, 11th, 15th. Anyone else? May. Ooh, close one. So, we're getting pretty close here. We have a match. We had a couple close ones.
I actually had a match in my calc class that I took. There was only 12 people in it, and we had a match in ours.
Anybody in June? That's me. So I think we've got one so far. July. No matches there. August. Oops, I think I'm just texting not everybody. So sorry. For August, we had August 2nd. I meant to email to text everyone, but just went to Yukian. August 27th for my wife. No match there. September. October. See, the suspense is gone at this point. I should have started in December and worked my way back. Nobody in October. We're very like front loaded in like the spring birthdays, spring and winter. November. And lastly, any Decembers? All right, so we had one match. I was gonna then say if we had more than one, we could calculate what are the odds of having more than one match. Okay, so the question is, we could test this empirically. We had one match. So let's think about how we can develop some machinery in order to calculate this. So I've got to guess out of 5 out of 61. Where'd you get that one from?
366 days if you include leap day. And then I put the number of people in the class, the 30, since we doubled it over the number of days out of the year.
So you have 30 out of 366. That's the idea. Okay. So let's see how this goes. And I just want to say I didn't mention this when I had our Canvas page open, that the materials that we're working with right now, these are going to all be posted prior to class. So usually we're going to be working through worksheets together. So we'll start with this first worksheet, Intro to Probability. So it might be useful to you if you're going to take notes on paper to print these out before class, but that's your call. So it will kind of be working through problem sets together in class. Okay, so I will open up this first worksheet. Okay, and so this is kind of the flow of them, and got some questions, and we'll kind of work through some of these together, and you'll be working through some of them with your classmates in breakout rooms. Okay, so yes, Neil deGrasse Tyson, he makes a lot of really good tweets, but yes, our brains as humans are not really hardwired to intuitively pick up on some notions with statistics. And so whenever something kind of goes against what we might expect, like having a match of two birthdays, sometimes it's hard to kind of comprehend why that might be so possible. Is the 30 out of 366 the right way to think about this? So, right, the question is, well, how likely is this match? So here's some terminology that will help us set up a framework for studying this. So a statistical experiment is a random activity that results in an outcome. So here, our statistical experiment is 30 people in a room matching birthdays. That was our experiment. And the sample space would be all of the possible outcomes. And so to maybe simplify this a little bit, rather than think about 30 people, let's just think about there are 2 people in the room. What are the odds that you and this other person have the same birthday? And we're going to assume, I apologize for people that are born on February 29th, we're going to assume non-leap years. So we're going to assume that there's 365 days. And I'm going to make another assumption that everybody is equally likely to be born on any single day. Like you're not any more likely to be born on January 1st as you are on January 2nd. And that's not exactly right, but it's pretty close to being a good assumption. So if we have 2 people in the room, several outcomes we would call like an outcome is one result or one observation. So I pick 2 people, and maybe someone is born on January 1st and the other person is born on February 3rd. Or, you know, we could have June 1st and June 1st, right? That would be an example of a match. So each of the outcomes would be a pair of birthdays. So if we think about the entire sample space, how many different outcomes could we have if 2 people are in the room? So how many?
Would it be
365, right?
So there's 365 that can go in that place. That's right.
And then 365 for the other one.
That's right. So altogether, how many pairs would we have then?
say factorial, 365 factorial, but that feels wrong because that'd be a huge number.
It's 365 times 365, right?
It is, that's right. We'll see factorials in a second, right? This is 365 squared, which is not as big as 365 factorial, but it's big. So there are like 133,225 different possible pairs. And so the sample space is not actually 365 or 366 because we have two people. So the first person has 365 possibilities, so does the second person. So this would be kind of like, out of how many events are we picking from? And so when we write out statistics, we generally use letters, like Latin letters, capital letters to represent an event. So an event is a collection of outcomes. So each of these things that we wrote up here, this is like outcome one, another outcome, and so on. And if we listed them all, we would have a whole lot of them, so I'm not going to do that. What is an example of an outcome which would be in the event that there is a match?
Outcome 2.
Sorry?
Outcome 2.
Yeah, outcome 2. That's right. So June 1, this would be one outcome that falls in the event M. So these are sets. So we could use like set notation to write this out. Probably you might think about starting with January 1st. So this would consist of all of the outcomes that we had up here that satisfy this condition that we would have a match. And so how many different outcomes are in this event M?
365.
Yep, got 365. So altogether, then we can think about, altogether there are this many possibilities. And out of all of those possibilities, 365 of them would have been a successful match. So one way that we can calculate probabilities, we'll get into this a little bit more. So I wanted to calculate what is the probability that event M occurs. That's what this notation up top means. We could say, what is the size of the sample space? What are all of the possible pairs? And out of all of those, how many of them would be a success? So that would actually give us 1 over 365 if we reduce that. So for two people, not very likely at all. So, you know, we've got, again, these terminology up here is really important. So this is how we're going to be able to talk to each other about probabilities. So the sample space, again, is like all of the possible outcomes. An outcome is one possible thing in the sample space, and an event would be the subset of the sample space that satisfies the condition for the event. Okay, so let's take a look at question 2, unless someone has a question. Okay, so now let's say, here's the statistical experiment, is I'm gonna pick a random person from the class. And I'm gonna observe the average of that student for the semester. So the sample space here would consist of what possible outcomes? Let's say, I don't know, pick Justin. What would you hope your outcome is?
Hopefully 100%, but I'm not sure that's going to happen.
Well, let's hope. That's good. So yeah, we got 100% on the upper end, right? So certainly it's possible someone could do perfect work all semester long. And then what would be on the worst side of things?
0.
0. So this sample space we would write as like an entire continuous interval of values. So up top, the first example we looked at, we had kind of discrete cases where it was a set and we're not actually picking values. We had dates, and dates are a discrete thing. Down here, this would be an example of a continuous sample space because your average could be 93.678, not right, can go on forever. So it's possible that you could have an average anywhere between 0 and 100. And kind of one key distinction here, that this is a continuous sample space, since again, we can get any value in between 0 and 100. So that's kind of the equivalent of like all of the pairs of dates. So this is all of the possible values. And then if we want to say what values would be in the event that a student passes the course, we'll call that pass.
Are we talking pass for a prerequisite, like you have to have a B in order to move forward, or just pass period?
Well, we'll say pass is D or above.
Okay.
Or I suppose we have D minus now, they added that. Yeah, that's right. But as the advisor, that's a very good point, that if you want to take a class that has this as a prerequisite, that would be another question, then you would want to get at least a C. That's right. But if we assume D minus or above is passing, certainly if you get 100, you're going to pass what would be kind of the lower end of that set.
60?
Yep. So these events are a subset of the sample space. Okay, so sample spaces are sets, events are subsets of that. Okay, and so maybe I'll come back to this in a second, but this might be something good to think about. So we've talked about the idea of a continuous versus a discrete sample space, and we also have an infinite versus a finite sample space. So an infinite sample space would be a sample space that has an infinite number of outcomes in it. So up top over here, this would not be an example of infinite sample space because we could actually, if we had a whole bunch of time, we could just list them all out. So an infinite sample space would be one where this answer over here is how many things are in here, infinity. Okay, so some notation that we can use when we're working with sets. So in some sense, probability is just like an application of set theory, is that we typically use the Greek letter omega, capital omega for the sample space, and we use a lowercase omega to denote one event or one outcome in that sample space. And for those that might not have seen other come across set notation, this C over here means the complement of event A. So this would, and we'll kind of draw some Venn diagrams to illustrate these. We use what's called the cup symbol to represent the union of two sets, which would mean all of the elements that are in A or in B. Whereas when we take that kind of smile and flip it upside down, and it now becomes a frown, that's an intersection. That means the set of elements that are in both of A and B. So if I'm looking for the complement of A, ooh, sorry, I think there's a chat. So if we looking at the Venn diagram, I want to shade in the area for the complement of A. You guys know how to annotate this? I think, can you annotate what I'm sharing? Maybe not. What would that shading?
Yes, we can annotate.
Does anyone want to shade in this region? That would be A. There we go. Yep. Got it. Yeah. So that's right. So the complement would be, that's right, all of the stuff outside of A. Oh. So these are called Venn diagrams if you haven't seen these before. They're a nice, useful way of visualizing these relationships with sets. If we were to talk about A union B, what would that look like? You can, if you want to describe in words, that works too.
Is that wrong? I'm sorry.
That's okay. What do you guys think? So
it'd be everything in A or B, right?
Yeah.
So,
So what?
Filling up all of A and all of B.
Yeah. So what was Let me just see if I can come back to this. So this was here first. What actually is represented there?
Would that be the intersection?
That's right. So this is actually the intersection. So this would go over here. So when it looks like the upside down symbol, that means it's going to be all of the, oh, I see, this stuff goes around. That's going to be
it does.
the stuff that is in both A and B. So it's going to be the region that falls inside of both of those circles. That's right. And the union, no, would be all of the stuff in both of these circles. And then lastly, A minus B, this is all of the elements that are in set A, but not in set B. So it's kind of like here's all the stuff in set A, but we don't want this stuff in here because that stuff is in B, right? So it's all of the stuff in A, subtracting out the stuff that's in B. That's right. So it would be the stuff in blue. That's right there.
Actually, I have a question.
Yeah.
Are you going to upload this worksheet?
Yeah, I upload the solutions. Yeah.
Okay, cool.
Yeah. So whatever we write up in class, I just send this to a PDF and upload that. Okay. Any questions about that terminology? Okay, so let's try a little bit of practice. So maybe we'll do a couple together and let's see how much more. Yeah, so here's the scenario. So we have 5 people that are applying for a pair of jobs. We have 5 people that are fighting for 2 positions. And let's say that 2 of the people that have applied identify as male, and 3 identify as male, 2 as women. And the employer is going to pick 2 of these people out of the 5 applicants for the job. So using some set notation, we want to write out the sample space and some events, how many things are in some of these events. So if S is the set of all possible outcomes for the employer's selection, then right, we've got these 5 people, and each observation is a pair, right? 2 people that were hired. So how many options are there for the first person?
Five.
Yeah, so over here, we can pick any one of those 5 people, right? So we could have like an M1 and an M2, that's a possibility. So we have 5 things that can go in the first position, and then how many possibilities are there in the second position?
4.
And we've got 4, right? Since you can't hire the same person for 2 jobs, we'll assume that. So that tells us that this sample space right over here, so we could use this notation of kind of like the absolute value to denote like how many elements are in that set. That's what that notation means. It's called the cardinality. And so we could write them all out. There's 20 of them, so I'm not going to do it. But sometimes it helps to write out, when you're dealing with a complicated problem like the birthday problem, it actually helps to write out the sample space sometimes, or at least a couple of things before you can generalize a pattern. All right, so we've got 20 of those. Yes, yeah, so sorry, just to clarify about, I just saw some chats. The blank one is up online, and this thing that I'm annotating right now, I will send to a PDF and also upload that. So in Canvas, you'll have a blank one and you'll have an annotated one. They'll both be up there. But for now, you don't get the annotated one until we earn it together in class. So we'll go through those together. Okay, so if set A is denoting the selection of 2 men, then how many different ways could that happen? So if I have a M1 here, how many other things might we have?
M2, and then M1 first, and then M2 second. Or sorry, M2 second, and then M1 first. Sorry, I just said the same thing backwards. M2 second, or M2 first, M1 second.
So the question here is, does the ordering matter?
Oh.
And that's a really good question. I'm actually reading my own question to see where in this problem it might say this. So I think it's, I bolded it to help myself. So the fact that these 2 jobs are identical means, right, putting this one first and this one second is no different than M2 and M1. They're hired for the 2 same jobs, yeah. So in this case, ordering doesn't matter. Certainly there'll be some cases where the ordering does matter, yeah.
Then we
so
got,
like if one of them was like an executive and the other one was vice president, you know, if they were like different positions, then the ordering would matter. It would be different that M1 is the CEO and M2 is, you know, whatever, something else.
Gotcha. So then you can put W1.
So event A is 2 men are selected. So we have an M1 and an M2. What else could we have?
M1 and M3.
What else?
M2 and M3.
Yep. And I think that exhausts all of the possibilities, right? So we have 3 different ways of hiring 2 men. So that would mean the odds of hiring 2 males in this case would be the 3 over here out of the 20 that we had over there. So this would be considered what is the probability that event A occurs. And I'll just say, like, this is maybe not a fairly simple thing to think about, but it's actually really relevant in terms of studying, you know, like hiring practices and things like this, where you want to make sure that, you know, you're not hiring biased towards certain gender or race or other things. You take a look at how many people applied from different groups and what was the hiring. Okay, that would be really unlikely that the 2 males were the most qualified. Something weird might have happened. Okay, so event B is at least 1 woman is hired. So, for example, right, that would be 1 woman hired.
So then you could have M2 W1 and then M3 W1 and then, as McKenna said, W1 W2.
So this is right, all of these, and then we certainly could hire both of the women. That's right, that would be at least 1 woman. What else are we missing here?
In that first one, you just put W2, like you just repeat that. So M1,
Yeah.
W2. Yeah.
That's right. We could hire M1 and W2, M2 and W2, M3, W2. So this is 1, 2, 3, 4, 5, 6, 7. Right, 7 outcomes would fall into that event. And so this is, you know, the most basic way to do statistics, but it's really nice. I mean, it is just how many things am I picking from? How many things satisfy my condition? And that's how we can calculate these probabilities. So if we wanted to calculate B complement, how many things would be in that set, even if we don't have to write them out?
13.
Yeah, and how did you get that?
20 minus 7.
That's right. Yep. So this is equal to all of the things in the sample space that are not in set B. So if we have a sample space that has 20 elements, 7 of them are in B, then the other 13 have to be in B complement. And there's a lot, so I won't list them out, but certainly you could check that. If we are working with the union of these 2 sets, what would we get? You guys are getting restless, sorry. So if I wanted to
number of outcomes or the possible outcomes?
There's just a number of outcomes.
10.
Yeah, so we would have the 3 that we have over here, right? I mean, we could list them all out. These 3 are in A, and all of these are in B. And the thing that you would just want to be careful for is that you don't double count anything. So if there were some things over here that also appeared down here, then we would want to avoid any double counting. That's right. So this would be the 7 outcomes over there plus the 3 outcomes that were in B. And if I take a look at the intersection of these two sets, A intersects B, what would we get?
An empty set?
That's right. So this doesn't have any elements that are, or any outcomes that fall into both of those events. So that would be the empty set. So, you know, once we get into probabilities, it's really just identifying how many things are in these sets to help us find them. And then eventually, that's right, like you don't want to list all of the pairs of birthdays. So that's where some combinatorics comes in. If we can find some shortcuts for counting things without actually having to list out an exhaustive list, even better. Okay, so yeah, I think this will be a good place to stop. So we'll take a look at one more problem, and then we'll pick up in class next time talking about this. And I'll say, now that I know where we're going to end up, some of this stuff will be on the reading quiz, and I'll make a video about it since we didn't get to it in here. So you can watch that offline, and there'll be a couple of questions on that. So now let's consider we're tossing a fair coin, and we're going to keep tossing this fair coin until we get exactly 2 heads. So let's first think about this set over here, or this event. So event A is that it takes us 4 chances before we get our second head. So I'm going to use T to denote the first toss is a tail, and I'm going to use H to denote that the toss winds up being heads. So what's one way that we could get 2 heads out of that? It takes us 4 tosses to get them. So I flipped the first one. Yeah.
Is that talking about 2 heads in a row?
No, just 2 out of the 4 that give us heads. That's right. So something like the ones that, yeah. So something like a tail and then a head, and then a tail and then head. That would be one thing because okay, it took us 4 tries, and that's when we got our second head. So one thing that all of these should have is like if you had something like this would or would not be in this set, in this event. So how many, if the first toss is a head, the second toss is a head, how many tosses did it take for me to get a head? It took 2, right? So this would not fall into this event because this event is saying we're only going to consider the possible outcomes that take exactly 4 tosses. So that means, right, the last one should be a head. And then you kind of have 3 tosses before that. Out of the 3 tosses that happened first, exactly one of them should be a head. That's right. So that's kind of, this is one way to do it. Could have a tail, and a head. I think that was chatted in. That's right. And then there is a head, a tail, and a head. And that exhausts all of those possibilities. If we wanted to write out the full sample space, we'd be here a while. We could get something like a head and a head, right? That would be in the sample space. Right, we could keep listing this out. How many elements are in this set?
Indefinitely large.
Yeah, so this is going to be infinitely large. That's right, because we don't stop tossing until we get the second head. So in theory, I could toss 1,000 tails in a row, right? Or I could toss 1 million tails in a row. It takes me an infinitely long time in order to get 2 heads back to back. So one of the questions that we skipped over was, can you think of a discrete sample space which is infinite? And here's an example, right? This is discrete. It's not a continuous sample space, and there are infinite numbers of outcomes in here. So a complement, right? We could take a really long time to list that out. It would just be kind of all of the outcomes that require 2 tosses, 3 tosses, and we skip the 4, right? Or it requires 5 tosses and so on, where each of these things, right, consists of a whole bunch of outcomes. Okay, so yeah, I think what the goal will be for the quiz that's on due for Monday is going to be talking about the difference between what does it mean for events to be disjoint versus independent. So the independence is the worksheet that we'll talk about on Wednesday. So we'll talk about, you'll do some reading or watching about this. Take a look at the quiz before we meet again on Monday. And then we can kind of finish up this worksheet together on Monday, and we'll start talking about independent events as well. So that worksheet is up. So yeah, just give me some, I know you're anxious to take a quiz. Give me some time to write it. It'll be up sometime tomorrow. Great. Okay. Well, nice to see you all, meet some of you, and have a nice weekend. That was an easy week, right? It's already sort of the weekend by CU Denver standard, or at least if you're taking classes on Monday, Wednesday only, it is the weekend. And I'll see you guys on Monday. And if you have any questions over the weekend or tomorrow, whenever, just shoot me an email. Yeah, well, cool. See you guys on Wednesday or on Monday.
Take care.
Yeah.
Yeah,
Thank
and
you.
I'll post this recording if you
Thank
guys
you.
missed anything. Yep.
Thank you.